Alright, hey everyone. I'm going to go through some info on like terms for you guys today. So just to give you an indication of how this all works. Now, there are 3 rules that you need to remember when you're collecting like terms, right? Rule number 1 is they have to be the same pronumeral with the same power. Run out of space. That's not a great start, right? So I'll try and, maybe I'll move my big head out of the way. I'll put it down here. Right? So same pronumeral, same power. I got too confident writing my words too big and run out of space. But that's okay. Alright? So that's rule number 1. Same pronumeral, same power. Rule number 2 is the coefficients don't need to be the same. You know what, I'm just going to scribble that one out. Don't need to be the same. Alright? So the coefficients can be any value you want. Alright? And that doesn't matter as long as that the first rule is satisfied, I guess. And then the last term, saying the order of pronumerals. So the order that they come in does not matter. All right. And for a quick refresher on pronumerals, coefficients, whatever, essentially if you've got something here like 7x to the power of 3, this value here in the box is the coefficient, right? Meaning the number. This one here is the pronumeral, meaning the letter. And this right here is the power, which you should know from indices, I would hope, right? So yeah, they're the rules. So the pronumeral has to be the same with the same power. The coefficients, I'm going blurry again. The coefficients don't need to be the same, and the order of the pronumerals does not matter. So let's look at a few questions and see if we can figure them out. So the first one is 7k plus 9k. Now, because both of these are k's, these are considered to be like terms, right? So essentially what we're doing in this case is we're saying that there is 9 k's, right? All plus together, or 9 times k is another way to think of it. We've also got 7 k's plus together, and we essentially collect all of these into one number to simplify them down. So all we're doing in this case is we keep the k the same. The k is just carries through, and we plus our 2 coefficients together. So that should give me 16k. Alright, so let's have a look at another one. I've got x plus 7x. Now the pronumerals and the powers are the same. Coefficients are different, but that's okay. I can plus these 2 together. So again, I'm going to say the x carries through as normal. And then I'm left with, okay, far out, this is really blurry, isn't it? Just trying to adjust that a smidgy bit so it doesn't blur so much, but it doesn't seem too keen on it. Anyway, so the x's carry through, so x and x are together, and I plus these numbers together. But there isn't a number there. And think back to when we did indices. What does it mean if there's a letter without a number in front of it? Well, what number is there? Right? And that answer is 1. Right? If there's never a number there, it means 1 is there, because 1 times x is just x, so it doesn't change anything. So 7 plus 1 gives me 8x. Right? And the reason that's not a 0 there is because if it was 0 times x, well, anything times 0 is 0. So that would the whole value would just disappear. Alright, let's have a look at this one. Okay, so we've got 3ab plus 2a plus 2b. Now I know some of you are going to jump the gun and say that AB carries through and then I plus 3 and 2 is 5 and 2 is 7 and that's my answer. Right? This is a very common mistake. That is not right. We're not doing it that way. Right? And it's like, well, why not? It's because the prime numerals in each of these terms are different. Right? Remember, a term is something separated by a plus or a minus. Yeah? So this is just 2b on its own. There's no other just b's in this equation. Right? This is 2a on its own. There's no other with just a. This is 3ab on its own. There are no other ones that have a and b. Therefore, this is actually already in its simplest form. We can't make this any simpler than what it is now. Right? I know that's a little bit weird, but it's something you're going to have to get used to. The prime numerals have to match the whole way through. Let's look at another example. Right? Here I've got 3x squared plus 2x. And the question being, if the prime numeral carries through, is my answer x or x squared? That's a good question. It doesn't work, right? You can't just pick one willy-nilly. It doesn't work that way. So what we do have is we have our rules at the top of the page here. Remember rule number 1. Same prime numeral with the same power. These have different powers, right? Therefore, this can't be done either, right? So that can't be done. So this just stays, the answer is just the form that it's already in. Because I can't do anything. I can't collect them in any way. What about this one? I've got 2xy plus 8yx. It's like, okay, can I collect these two terms? Well, if you look at our rules, rule number 3, the order of the prime numerals does not matter, right? So these are like terms because they've got the same letters. It doesn't matter that they're in a different order. So just as before, 2 plus 8 gives me 10. And then x and y just carry through, right? And if you're wondering what order do I write these in for my answer, just remember the rule from when we first started, which was, generally speaking, you want to write your prime numerals in alphabetical order. You're not going to get the question wrong if you don't do that, but it's just a nice way of keeping track. I'm just going to adjust this so you can see the last question. So I decided to put in a hard one just to really freak you out a little bit. If it'll come into focus, that would be terrific. Okay, so what I'm going to do here is I've got a whole bunch of like terms to collect here. And I think the best way to do it is to just sort of label them. All right. So firstly, I've got 2a. All right. I'm going to look through and see, are there any other terms that are a number and just a? Well, I've got 7a. I've got 4a. Right? Now, because these are all plus together, we can use the commutative law, which suggests that you can change the order of things that are plus together in the same way that 4 plus 8 is 12, and so is 8 plus 4. It doesn't matter which way those numbers are around, the answer is still the same. So we can rearrange all of these numbers here to put these ones next to each other. And that's going to help us out a bit. So I'm going to say 2a. I'm just going to put a cross through each number as I write it down. This is so I don't lose track of which ones I've written down. So 2a plus 7a plus 4a. Right, I've got all them next to each other. Now we're going to do the same thing here. I've got 4ab. Do I have any other ab's? Well, I've got 3ab. Right, so I'm going to take over, so plus 4ab. And then plus 3ab. Right, and same as before, I'm just going to cross them off to say I'm done with those. There's no other ab's. Then I've got 8y. There are no other y's, so then I've got plus 6. Now these are all next to each other. It's going to make this much easier to answer. So same as before, I'm plussing 2a, 7a, and 4a. Right? Let's just ignore the rest of it for now. So my answer will be something a, because the a carries through. 2 plus 7 plus 4, well that's 13. So 13a plus, now I've got to deal with these ABs. I got 4AB plus 3AB. So again, it's going to be something AB will be my answer. I do 4 plus 3, which gives me 7. 7AB. Then I have 8Y, and then I have 6. I can't collect these terms any more than that because none of them are the same now. Right? So that's actually my answer. And I know that that's probably a little bit hard, but I think that it's important to go through something like that. I'm just going to add another question here underneath. Let's say I had something like 3AB plus 4B minus 2AB plus 2A minus B, right? So again, I'm going to try and do the same thing and arrange everything together. So I'm going to do my 3AB first. Are there any other ABs? Now when I get my 2AB, it's important to note that the sign in front has to go with it when you shift things around. Alright? Because otherwise you're going to stuff up your question and then that minus might disappear. So it's important to take the sign with it. Then we've got plus 4B. Right? So plus 4B. And I've got a minus B on the end. Minus B plus 2A is my last one. Alright? So I can solve these now. 3AB minus 2AB. Well, again, my answer should be AB. 3 minus 2 is 1. So I could write a 1 in front. Or I can just leave it as AB. It doesn't matter. So I'm going to say AB plus 4AB minus B. Remember, if there's nothing in front of the B, that means 1. So the B carries through. 4 minus 1 is 3. Okay, and then I've got plus 2A on the end. Plus 2A. Alright, so essentially you're breaking them down into little problems and solving them as you go. I think that's all I wanted to show you in terms of collecting like terms. I'm just going to double check and make sure that that's all of it. Yeah, that's everything that I want to show you. So feel free to go back and re-watch this video if you need the support, but otherwise get stuck into some work. Thank you. Take it easy. Bye.